Well, here we go. We're going to multiply some binomials. Over here, we're going to use the FOIL method. It says first, outside, inside, last. It's really just the distributive property a few times over. But we'll use the FOIL method. So here is the first two factors, root 7 times root 5. That's root 35. Then the outside two, minus 3 root 7. Then the inside two, plus 2 root 5. And finally the last two, minus 6. Oh, and I didn't have to try to squeeze that in. I'm done. That's interesting. And down here, same story. Maybe I'll write it down here. It looks like I have plenty of space. So this first one, square root of 14. And then it's the outside ones, minus the square root of 7 times 21. Then the inside, minus the square root of 2 times 10. And find the last two, plus the square root of 10 times 21. So this is 7 times 3 times 7. This is 2 times 2 times 5. And that's 2 times 5 times 3 times 7. Why am I doing that? Well, if there's any perfect squares under the radical sign, I have to factor them out in front as a single factor to simplify the radicals. So here we go. So the 14 is 2 times 7. It's got no squares. I have two 7s here, so I have minus 7 root 3 when I get done. There's two 2's there. Minus 2 root 5 when I get done. No common factors, no squares in there. So it's just this product under the radical sign. 10 times 21 is 210. All right. I should put this down here, but I'm just not moving it. So one way to find the product of binomials is using the FOIL method. Another way is to use formulas we know. Here's the perfect square formula. A plus b squared is a squared plus 2ab plus b squared. It's something nice to know. And so we'll just apply it here to this a and this b. So it will be a squared, so that's root 3 squared is 3. And I've got twice the product, so twice 7 times root 3 is 14 root 3. And I've got b squared is 49. Okay. Oh, we're not done, okay. And then we're going to combine things that we can. So that's 52 plus 14 root 3. Okay. And here we have the difference of squares formula. A plus b times a minus b is a squared minus b squared. And this is not an a, it's actually a 9. And that's actually an a. I have that problem. So when you have same thing, plus and minus, you get the first thing squared minus the second thing squared. So that's 81 is the first thing squared minus. Then I have root 5 squared, and root 5 squared is just 5. And 81 minus 5 has got to be 76. So we multiplied some binomials using the FOIL method, and also using a couple of formulas we know, perfect square formula, and the difference of squares formula. This difference of squares formula is going to come in handy later. We try using it to rationalize the denominator. We call these two types of expressions conjugates, where they're the identical terms with opposite signs in between them. We call those conjugates. So we'll be using conjugates to rationalize denominators shortly. I'll be back with more multiplying and dividing radical expressions in the next slide.